All right, in this video, we are going to talk about suggested homework problems from 7.6, and we'll be talking about moments, center of mass, centroids, specifically with planar lamina. So let's go ahead and first discuss how mass and weight are different from each other. This is kind of a long explanation. So mass is the measure of a body's resistance to change in motion. Think about the laws of motion, that an object in motion tends to stay in motion until an outside force acts upon it. An object at rest tends to stay at rest until an outside force acts upon it. An object with a small amount of mass is easy to set into motion and easy to make it change its motion once it's started. An object with greater mass is more resistant to change. It's harder to get it started moving. It's harder to stop it once it starts moving. It's harder to make it change its motion once it's moving. So mass is independent of the force of gravity, and is the same everywhere. I'll just say everywhere in the universe. Okay. Weight is a force in the direction of gravity. Gravity is an acceleration. And is equal to the mass times the acceleration due to gravity. So F sub G, I'll call weight, is equal to mg, where G is equal to acceleration due to gravity. Weight changes as you get closer or farther away from the center of mass of the object pulling on you. Really, gravity is an attraction between objects, and the more massive object is going to have more of a gravitational pull on the object with less mass. You can kind of think of it in a way like magnetism, where a strong magnet is going to pull things, even big things, other magnetic things or ferrous objects from further away. Other times, if it's a weaker magnet, then you have to get it closer to the magnet for it to be affected by its magnetism. It's kind of the same idea with gravity. So gravity really is this attraction between two objects in physics, and the larger the bodies, the more they interact with one another. But for right now, it's important to know this relationship that we're just dealing with ourselves right here on Earth right now, and that our weight is equal to mass times acceleration due to gravity. And that acceleration due to gravity is actually going to change as we get closer to the center of the Earth or further away from the center of the Earth. And we are talking about center of mass here, and that's how that's related to this section that we're in. Okay, long explanation to a short question, but it's important that you understand those physics concepts, that mass and weight are related to each other, but different. That's why it's kind of not right to talk about somebody's weight in kilograms. That's a measure of their mass. Pounds are a measure of force. That would be a correct measurement of weight. It's not correct to give somebody's mass in pounds. There's another unit of mass in the engineering system called a slug, and that newtons would really be the correct way to measure somebody's weight in the metric system. So mass, like grams, kilograms, and slugs would be the engineering system. Weight would be in pounds or newtons, so that you know the units of those things. All right, that was a lot of preliminary discussion. Let's talk about what a planar lamina is now. So it's got the name plane in it, planar. So we're talking about something that is flat like a plane. Think of a piece of paper, right? And the important concepts here are that a planar lamina is a flat. By flat, I mean basically no thickness, virtually no thickness plate, we'll call it. Think of this like a plane that's infinite in 2 dimensions, right? But of material, to be made out of anything. We'll call it a plate. Of material, maybe I'll say sheet, because you can think of a sheet of paper as well, of material, and you can think of like sheet metal. So a plate or sheet with virtually no thickness that has constant density throughout, and that constant density we're going to call the Greek letter rho. It looks like a P. It's kind of a fancy P, but it's a Greek letter rho. R-H-O, rho. It's very important that the density is constant, because we will not learn how to deal with variable density until calculus 3. So this will come back in calculus 3, and you'll talk about how to find this when the density is not constant. All right, let's look at number 7. This is the most basic type of problem. It may kind of be hard to tell where the problem number 7 information is, but it's right there. So let me just highlight it here that it is here. That's what we're interested in right there. Okay, so M1 is 1, M2 is 3, M3 is 2, M4 is 9, and M5 is 5. X1 is 6, X2 is 10, X3 is 3, X4 is 2, and X5 is 4. The idea is we're all on one side of the x-axis here with different weights, and where would the fulcrum be here, the balance. If I were trying to find the balancing point here, where would x bar be? So my equation for x bar says to take the mass times its distance, 1 times 6, and the next mass times its distance, 3 times 10, plus the next mass times its distance, 2 times 3, times the next mass times its distance, 9 times 2, plus the next mass times its distance, 5 times 4, and I'm going to divide it by the total mass of the system, 1 plus 3 plus 2 plus 9 plus 5. So x bar is going to be 6 plus 30 plus 6 plus 18 plus 20 over 4, 6, 15, 20. X bar is going to be 36, 42, 60, and 20 is 80 over 20. So that gives me an X bar of 4. All right. Let's look at number 15. So we're starting to talk about planar lamina with uniform density. Y is equal to 1/2 x, y equals 0, x equals 2. Let's go ahead and draw a picture of this for you so you can see the region that we're talking about. Up 1, right 2 is here. And so we're talking about this triangle right here with vertices of 0, 0, 2, 0, and 2, 1. That's my planar lamina that I'm interested in, and I want to find the centroid of that region. So to find lowercase m that I'll need, I need to find my f of x here is my upper function, which is 1/2 x, and my g of x, my lower function, is y equals 0 here. So m is going to be rho integral lower x value to upper x value f of x minus g of x. So that's 1/2 x dx is going to be rho over 4 x squared from 0 to 2 is going to be 4 over 4 is 1. So that's just rho. My capital M sub x is going to be rho integral 0 to 2. So that's my boundaries there. And then I want the average value of my functions times the difference in my functions. So average value of the functions here, this one plus this one divided by 2, that's 1/4 x times, and then the difference of the functions is 1/2 x dx. So that's going to be rho over 8 integral 0 to 2 of x squared dx. That's rho over 8 times x cubed over 3 from 0 to 2. That is rho over 8 times 8/3. 8s will cancel and I get rho over 3. Capital M sub y is equal to rho 0 to 2 of, and now I need to find x times the difference between f of x and g of x, which in this case is 1/2 x dx, is rho over 2 integral 0 to 2 of x squared dx. That gives me rho over 2 x cubed over 3 from 0 to 2 is rho over 2 times 8/3. 2 goes into 8 4 times is 4 rho over 3. So now my x bar is m sub y over m is 4 rho over 3 times the reciprocal of m, which is 1 over rho here. Rows will cancel, and this is 4/3. My y bar is my m sub x over m is going to be rho over 3 times 1 over rho is going to be 1/3. So my x bar, y bar for my centroid is 4/3, 1/3. And I can come back to my picture here and say 4/3 is 1 1/3, and then 1/3 is somewhere up here. And that makes sense that it's shifted to the right a little bit and down a little bit because most of the area of the triangle is in that bottom right portion. So there's more weight, if you want to call it there, pulling the centroid to where it's more massive. There's less stuff over here, more stuff over here, more stuff down, less stuff up. So it's going to pull it down and right a little bit. And it's not going to be exactly in the center unless I have an object that is like a square that's the same on all sides, or even a rectangle. You could find the midpoint of each side of the rectangle and go up there into the middle of the rectangle, and that will be the centroid of a planar lamina that is a rectangular shape. So we're not going to usually do things that are that easy with rectangles and squares and things like that. We're going to do things that involve calculus, so we're going to have curves and areas between curves and so on. So number 19, y is equal to x squared, y is equal to x cubed. And remember that these are going to intersect at 0 0 and 1 1. And the x squared is above x cubed in that region because the square of a fraction is bigger than the cube of a fraction. So that's what I'm talking about here, that my f of x is going to be x squared is my upper, and my g of x will be my x cubed will be my lower. So m is equal to rho from 0 to 1 of x squared minus x cubed. Dx is rho, and then this is x cubed over 3 minus x to the 4th over 1, or over 4, from 0 to 1 is rho times 1/3 minus 1/4 is rho over 12. Capital M sub x is rho 0 to 1 of average of these functions times difference of these functions, like so. And this is rho over 2, 0 to 1. And then these are same numbers, opposite signs. So this is x to the 4th minus x to the 6th because of my difference of cubes formula. I'm sorry, difference of squares formula. And this is rho over 2. And then this is x to the 5th over 5 minus x to the 7th over 7 from 0 to 1. So that's rho over 2 times 1/5 minus 1/7 is rho over 2 times 7 minus 5 is 2 over 35. 2's will cancel, and that's rho over 35. My m sub y is rho 0 to 1 of x times x squared minus x cubed dx is rho 0 to 1 of x cubed minus x to the 4th dx. And so this is rho x to the 4th over 4 minus x to the 5th over 5. 0 to 1 is rho 1/4 minus 1/5 is rho over 20. So x bar is my over m is rho over 20 times the reciprocal of m is 12 over rho, and this is 3 over 5. Y bar is mx over m is rho over 35 times the reciprocal of m is 12 over rho. So y bar is 12 over 35. There's no way of simplifying that. So my x bar, y bar is equal to 3 over 5, 12 over 35. Moving right along to number 27. X is equal to a negative y. X is equal to 2y minus y squared. You may notice that these are written as x as a function of y instead of y as a function of x. The idea doesn't change, just the formulas are going to be modified just a little bit to accommodate the x as a function of y now. Let's go ahead and sketch a graph to see which function is to the right and which is to the left. So this one, x is negative y. There's a line like that. This one has y is 0 and y is 2 for its y-intercepts. And when y is 1, we have 2 minus 1 is 1. So it's a parabola that opens to the left. And we see that it has a point of intersection there at, my goodness, I'm not doing well drawing this. See, it has a point of intersection here at 0, 0. and then it has another point of intersection up here that I'll solve for. Negative y is 2y minus y squared. Y squared minus 3y is equal to 0. Y times y minus 3 is equal to 0. So y is equal to 3. Y is equal to 0 are my points of intersection. If y is 3, x is negative 3. So we're at negative 3, 3, and 0, 0 for our points of intersection here. We're talking about this bounded region right here. I'm not even going to try to estimate where the centroid of that would be because it's really funny shaped, but M is going to be rho, and then Y is going from 0 to 3 here, and we have the difference of the functions. So the parabola is to the right and the line is to the left. So we have 2y minus y squared minus a negative y dy. So this is rho 0 to 3 of 3y minus y squared dy. I'll be using that over and over again. So rho, let's see, 3y squared over 2 minus y cubed over 3 from 0 to 3 is rho times 27 over 2 minus 27 over 3. So let's make this 27 rho times 1/2 minus 1/3. 3 minus 2 is 1 over 6. So that's 27 rho over 6 divisible by 3 is 9 rho over 2. So there's my M. Now I'm ready for my M sub Y. So normally I find my M sub X first, but because X and Y changed, they're changing subscripts, but this is really the same thing as what I did with M sub X. So I'm going to find the 0 to 3. I'm going to find the average of the functions times the difference of the functions. So add the functions together here is y minus y squared over 2. And then the difference of the functions here is 3y minus y squared and dy. So this is rho over 2, 0 to 3 of y times 3y is 3y squared. Y times negative y squared is negative y cubed. Negative y squared times 3y is negative 3y cubed. Negative y squared times negative y squared is positive y to the 4th dy. So rho over 2, 0 to 3. Let's write this in descending order. Y to the 4th minus 4y to the 3rd plus 3y squared dy. So rho over 2 times y to the 5th over 5 minus y to the 4th plus y to the 3rd from 0 to 3. So rho over 2 times, and then this is big number here, 243 over 5 minus 81 plus 27. Okay, well, 27 comes out of everything. So let's write that there right now. And that was 9/5 minus 3 plus 1. So 9/27 rho over 2 times 9/5 minus 2 over 1, which is 27 rho over 2 times a negative 1/5 will be a negative 27 rho over 10. And that's my my. My mx is going to be the row 0 to 3. Now my multiplier is going to be y instead of x times the difference between the functions here, dy. So this is row 0 to 3 of 3y squared minus y cubed. Dy is rho, and then we have y cubed minus 1/4 y to the 4th from 0 to 3 is equal to rho times 27 minus 1/4 of 81, and 27 can come out. 1 minus 3/4 is 1/4. So this is 27 rho over 4. All right, so now that I have all of those things, hopefully you have them all written down, but as a recap here, m is equal to 9 rho over 2, m sub y is equal to negative 27 rho over 10, and m sub x is equal to 27 rho over 4. Then we have x bar is still going to be my over m is going to be negative 27 rho over 10 times the reciprocal of m is 2 over 9 rho. Rows cancel. 9 goes into 27 3 times. 2 goes into 10 5 times, and I end up with negative 3/5 for my x bar. My y bar is going to be my m sub x over my m. Let me move this up. Y bar is m sub x over m. And that is going to be 9 rho over 2. Sorry, that is 27 rho over 4 times 2 over 9 rho. Rows will cancel. 9 goes into 27 3 times. 2 goes into 4 2 times. I end up with 3/2. So my x bar, y bar for my centroid is equal to a negative 3/5, 3/2, or if you prefer, negative 6/10, 1.5. So let's come back to my graph here, and negative 6/10, 1.5 is somewhere up in here. Let's go ahead and look now at 33. 33 is going to require us to choose a convenient coordinate system. I'm going to try my best to sketch everything here for you. It's very symmetric. Okay, So what I'm going to do is choose this point down here to be 0, 0. And I'll just draw this line up here through the middle. I'm going to imagine that I'm going to cut this into these various rectangles here that are this one that's 3 by 5 right here. It's going to have its centroid halfway up at 0, 3/2. Now this one starts at y equals 3 up here, and it has half of 4 is 2, so 3 plus 2 is going to be 5, 0, 5 for its centroid. And then we have this one starts at 3, and 4 is y equals 7 is this line right here, and we go up 1/2 to 7.5 or 15/2, so 0, 15/2 is where the centroid of that little bit is. Now let's talk about the area of each of these small pieces. 7 by 1 is 7. 4 by 3. Yes, because 2 and 2 is 4, away from 7 is 3, so 3 by 4. This one in the middle is 12, and 3 by 5 is 15. So I'm going to use those areas as the weights here. My X bar is super easy since everything lies on this X equals, or on that line there, but it's going to be the weight of 15 times the X coordinate of this point is 0, plus this weight of 12 times that X coordinate is 0, plus this weight of 7 times that X coordinate there is 0, over my total of my weights, which is 15 plus 12 plus 7 is 2734. 0 over 34 is 0. My Y bar is going to be 15 times 3/2 plus 12 times 5 plus 7 times 15 halves over, and the total weight here is still 34. So Y bar is going to be, let's see, 45 halves plus 60 plus 105 halves over 34. These halves can add together and make 150 over 2 is 75, plus 60 over 34 is 135 over 34, which does not simplify. And so my Y bar is approximately 3.97. So X bar, Y bar is exactly 0, 135 over 34, and is approximately 0, 3.97. 135 over 34, you can see is not exactly 3.97, but it's pretty close to that. All right, now for the really long problem. So it's an interesting problem, especially if you're a math person, but it is deceptively short in the question here. So I'm going to read it, and then I'm going to show you the picture because the picture is telling you everything that it says in words here. Then I'm going to draw the picture and I'm going to do my work. So for a trapezoid, find the centroid of the trapezoid with vertices 0, 0, 0A, CB, and C0, and show that the intersection of the lines connecting the midpoints of the parallel sides and the line connecting the extended parallel sides, as shown in the figure, is the centroid. So first, let's find the centroid, and then we'll find equations of those lines and find the point of the intersection, and then we'll find out that they are the same thing. We're going to need to pick an equation for our constant density rho, and I'm going to call it 1 divided by the area. So rho is going to be 1 over A here. And my A is area of my trapezoid is going to be the average height times the length of the base. So length of the base times add my parallel sides A and B, divide by 2. So that is C times A plus B over 2 for my area function. So my rho here is going to be 2 over C times A plus B. All right. My X bar is going to be this rho. Going from 0 to C of, and this is my M sub Y, X times, all right, now I guess I should define the two functions that are here. So, so you can see where this is coming from. So we have let's define lines L and M here, and I'm just going to call this line here L and this one here M, and we have these functions that are the lines here. So I'm going to deal first with this line that is right here that has a y-intercept of A. So my f of x, my upper function, is change in y is b minus a over c x plus a. My g of x is my lower function that is y equals 0. So we'll get to L and M in just a minute, well, several minutes, but X bar is again going to be rho, which is 2 over C times A plus B, integral 0 to C of the X times the difference in the functions here is B minus A over C x plus A dx. And so that's going to be equal to 2 over C times A plus B, 0 to C of B minus A over C x squared plus AX dx. That's 2 over C times A plus B, and then we have times B minus A over 3C x cubed plus AX squared over 2 from 0 to C. So this will be 2 over C times A plus B times, and then we have b minus a, and then that'll be c squared because it becomes c cubed divided by c over 3 plus ac squared over 2. So let's make a common denominator of 6. On the inside, 2 over c, a plus b. And this is going to be 2 b minus a c squared plus 3ac squared over 6. I know that this 2 is going to go into there 3 times. This is what my x bar is going to be. X bar is 1 over c, a plus b, and then this is 2bc squared minus 2ac squared plus 3ac squared over 3. So x bar is 3c a plus b, and then we have ac squared minus 2b c squared, and then let's factor c squared out, a minus 2b over 3c, a plus b. C goes into c squared c times, and x bar is going to be c times a minus 2b over 3 times a plus b. So plus, not minus, plus 2bc. So there we go. That's my x bar. Now, for my y bar. Y bar is going to be that row that we talked about, 2 over c times a plus b, integral 0 to c of the average value of these two functions. So remember that my functions are right here, b minus a over cx plus a and 0. So I'm just going to pull the 1/2 out of that. B minus a over c x plus a, and then the difference between the functions is going to be the same thing. So when I multiply, that's squared dx, and this is going to be y bar is 1 over c times a plus b, and then we have 0 to c of b minus a over c quantity squared x squared minus 2 b minus a over c times a, so minus 2a times that plus a squared dx. This is plus, not minus. Why did I write minus? Plus a. That's my function. So plus there. Y bar is 1 over c, a plus b. Then we have constant b minus a squared over c squared. And then this is x cubed over 3 plus, this is x a, b minus a over c, x squared over 2 cancels out with that 2, plus a squared x from 0 to c. Y bar is 1 over c times a plus b, and this is b squared minus 2ab plus a squared over 3c squared times c cubed, and that will give me a c plus ab minus a squared over c squared. It's going to give me a c plus c plus a squared c. Zeros drop out. So common factor of c, and everything can come out. Cancel. That leaves me with b squared minus 2ab plus a squared. I'll flip these around. A squared minus 2ab plus b squared, and then plus ab minus a squared plus a squared, and these zero each other out. And I have y bar, it's 1 over a plus b, and then I have over 3 a squared minus 2ab plus b squared plus 3ab. When I make a common denominator, y bar is a squared plus ab plus b squared, which doesn't factor, over 3 times a plus b. So my x bar, y bar, we have found to be a plus 2b times c over 3 times a plus b, and a squared plus ab plus b squared over 3 times a plus b. Let's go ahead now and find the equations of lines L and M as I've marked them, and find the point of intersection and see if it's the same thing. So line L here is going to be, let's actually talk about what these points are that L goes through. So line L goes through the point that is halfway up on this axis, which is 0, a over 2, and it goes through the point which has an x value of c, and is halfway up here, which is b over 2. So change in y, which is b over 2, minus change in x, a over 2, over c, x plus my y-intercept of a over 2 is going to give me b minus a over 2c x plus a over 2, and that's going to be line L. Line M is going to go through this point up here is C, and then it is B plus A when I extend, so A plus B, and it goes to the point down here that is going to be negative, so that's 0, negative B. So we have our slope of B minus negative B, so that's 2B over C minus 0 is C, X, plus a negative B, let's look at that again. A plus B, yeah, A plus 2B. So A plus B minus a negative B over C is my slope. And that's A plus 2B over C. So that's line M. And this is Y equals and Y equals. So line L and line M. So let's set the equations equal to each other to find their point of intersection. So B minus A over 2C X plus A over 2 is equal to A plus 2B over C X minus B. B minus A over 2C minus quantity A plus 2B over C times X is equal to a negative B minus A over 2. And let's multiply by 2 over 2 to make a common denominator here. B minus A minus 2A plus 4B over 2C. X is equal to, and let's make a common denominator here, negative 2B minus A over 2. And while I'm at it, I'll just multiply by C, and that way my denominators will be equal. So this is going to be negative 3A minus 3B over 2C. X is equal to negative 2B minus, so let's put this in alphabetical order, negative A minus 2B times C over 2C. And when I multiply by the reciprocal, X is a negative A plus 2B times C over 2C times 2C over a negative 3 times A plus B. 2 C's will cancel, negatives will cancel, and I'll be left with X is equal to A plus 2B times C over 3 times A plus B, which is what I got for my X bar. So my Y of that X bar value, pick either equation. I'm going to pick B minus A over 2C times this X value of A plus 2B times C over 3 times A plus B plus A over 2. And that's going to be C's will cancel here. Y bar is going to be B minus A over 2 times A plus 2B over 3 times A plus B. So this is plus A over 2. Y bar should be A B plus 2B squared minus A squared minus 2AB over 6 times A plus B plus A over 2 times 3 times A plus B, 3 times A plus B. Y bar should be equal to 6 A plus B, negative AB plus 2B squared minus A squared plus 3A times A is 3A squared plus 3A times B is 3AB over 6A plus B. So let's check and see if my Y bar comes out to be the same. 3A squared minus A squared is 2A squared. And then 3AB minus AB is plus 2AB plus 2B squared over 6 times A plus B. So this is 2 times A squared plus A B plus B squared over 6 times A plus B. 2 goes to the 6 3 times, and my Y bar was A squared plus AB plus B squared over 3 times A plus B, which is what my Y value of my point of intersection is as well. So we've just shown that the point of intersection of L and M, which I labeled, they weren't there to start off with, but it's just easier to write this, is the centroid X bar, Y bar for this trapezoid. Okay, that is it for this video. And that is it for chapter 7. So we'll come back next time and we'll start to talk about 8.1. See you for the next video.